Use compositions to determine whether f and g are inverse functions. So if I have f of x equal to the cube root of x minus 1, and my g of x equals x cubed plus 1, I can find my f of g, which is my f function when g functions plugged into f. Okay, so I'm plugging in this g of x function into this x here. So let's go ahead and do that. So it's going to equal the cube root of x cubed plus 1 minus 1. So it's the cube root of x cubed plus 1 minus 1. So the plus 1 and minus 1 will cancel out, and I have the cube root of x to the third. And so the cube root of x to the third, the 3's are going to basically cancel out, and I have left just x. So that works. And we want just x. And so let's go ahead and find the g of f. Which is the same as writing it as g with the input of function f of x, or we're putting in the function f of x into g. So this whole expression here is going to go into this x value here. So let's go ahead and demonstrate that. So I have the cube root of x minus 1 cubed plus 1. And so the cube of a cube root cancels out, and I have x minus 1 plus 1. The negative 1 plus 1 cancels out, and I'm left with x. So this works here. This works here. So that's a yes. Wow, yes. And yes. So these are inverse functions. Let's continue. Let's look at another example. So if I have the f of x equals 1/4 x plus 7, and the g of x equals 4x minus 7, and we want to know by using composites or composition to determine whether f and g are inverse functions. Again, we should get f's like last time. If we don't, then they're not inverse functions. So let's go ahead and see. So we have the f of g of x, and that can be written as f with the input of g of x. And so we're going to place this function here into this x here. So I'm going to have 1/4 times 4x minus 7 plus 7. So 1/4 times 4 is just going to give me 1. So I'm going to have 1x, or just x, minus 7. Ooh, error. timeout, apology, 1/4 times -7 is going to give me -7/4. And then now plus 7. And then I need to add these two fractions together. So I need to turn this into a fraction that has a 4 in the denominator. So that's going to be 28/4. Multiply top and bottom by 4. And I get 28/4 plus -7/4. And when I add these two together, I get x plus 21/4. So these do not cancel out, and I just do not get x by itself. So this is no, it's not inverse. And let's just check the other way out where we have g of f, which equals our function g when we plug in f of x. Okay, so when we do that, we're going to take this 1/4 x plus 7 and plug it into this x here. So it's going to be 4 times 1/4 x plus 7 minus 7. And 1/4 times 4 is just going to give me x. 4 times 7 is going to give me 28. And then I have the minus 7 out here. And so we have the g of f x equals x plus 28 minus 7. That's going to be 21. So again, I don't have x by itself, so this is also no. And so these two functions here are not inverse functions. So f of g or g of f with x do not give me just x. So these are not inverse functions.